transcends who I am, even though I have a long list of achievements, and it might be more credible for you to hear this from me than from a lot of other speakers. I feel that no matter who is standing and walking here on the stage today, whether they were one of the most famous scientists of all time, or whether they were some random nobody who just got their PhD in math, no matter who it was, I think that the message that they are about to give right here, I think the message that I am about to give transcends who I am in specific. And although I may give a few personal experiences here or there, I think they will be no different than the personal experiences any other experienced mathematician will give. So, today I would like to transcend exactly who I am and how famous I am, and no matter who is giving this message on the stage here today, whether it was the most famous mathematician and scientist of all time, or some random nobody who just got their PhD in math and science, no matter who they were, I think that the message should still be the same, and your reaction and your actions after the speech should be the same as well. No matter who is giving this speech today, and contains the same message. And although my personal narrative may be slightly unique, anybody else who's gone through math and science education will have almost the same experiences. So, today, I would like to talk about the importance of our new generation valuing, understanding, and learning math and science. Nowadays, I find so many people saying that math and science is for nerds, or that they weren't smart enough for math and science, or that they hated math, or that they were bad at math in school, or that they simply didn't see how math was useful. I've even seen people tell me, this is the second year I've gone without having to use sine, cos, and tan. So, I mean, that's great for you, but do you have a job? So what I would like to ask you all out there is, math and science is becoming increasingly important in today's future, especially in terms of technology and engineering. Nowadays, many of the best jobs are in engineering and computing. So, why is it that when math and science is gaining so much importance in our actual job market and our world for the next few years to come, why is it that when math is gaining importance in the job market, that math is losing importance to us and especially our newer generations? Why is it that instead of wanting to learn anything, especially anything that serves as difficult or a challenge, or anything that requires actual critical thinking to maneuver, why instead of doing that do we always want to keep it simple and easy? Why do we want to stick to the same basic kind of problems? Why do we never want to actually go out there and problem solve? So that's the question I would like to ask you, especially the younger generations, the people who are still in school or still in their first few years of college at this point. Why do you feel comfortable sticking to the same routine, the same kind of problems that use the same formulas and methods and equations that have only 1 to 2 steps at best, and at worst they're just a memorization problem, especially when it comes to subjects like physics, chemistry, and most notably biology. So instead of a memorization test where the one who gets the best mark is the one who has the best memory, I think that we should all move on by trying to understand something. Why don't we understand mathematics? And why can't we understand mathematics? And how is this harmful for us? I mean, what's really the problem? If we get good grades on our math and science tests, who really cares if we don't understand math and science? It won't really affect us in the long run, because all we'll have to do is a few simple calculations and problems when we actually get a job as a math and physics professional, right? But here's what I think. In the 17th, 18th, and 19th centuries, there was so much progress in math, mostly because people were not only very experimental, they always wanted to experiment with something new every single day. They looked for patterns in the digits of every number. Like, for example, it was discovered in the 17th, 18th, and 19th century that Pascal's triangle actually correlates to the digits of the powers of 11. and number theory as a whole was invented in that span of time. So was graph theory, and so were many other fields as well. Integral calculus, differential calculus, vector calculus. In the 18th and 19th centuries especially, electromagnetism was able to bloom, and so was regular mechanics, as Newton and a lot of other scientists worked on it, including Galileo, Faraday, etc. So there was such an explosion of new ideas and new understanding for those 200 or so years. So what happened? After those 200 to 250 years, why did we suddenly slow down? Of course, in the 20th century, there were many remarkable achievements too, most notably in physics, quantum mechanics, as well as special and general relativity, and in mathematics, topology. Well, why does it feel like we slowed down in the 20th century? And nowadays, we're 20% of the way through the 21st century already. In fact, nearly 25% of the way, 1/4 of the way through. And yet, none of us can name a single discovery that was made in that amount of time. Sure, we can name small things like discovering a new method for the quadratic formula, making slight progress on the Riemann zeta hypothesis. But we can't name anything big, any new fields that have been pioneered, any new experiments that have been made. And this is not an issue with the mindset of the professionals, the people with master's degrees and PhDs. Of course, they're just as passionate as anybody else in any other field. They understand math better than any of us do here. But the problem is that almost nobody nowadays feels inspired enough to get a PhD. The people who say they love STEM, and in the early and last few years of high school, the people who say they love STEM, half of them drop out once they actually get to college because they realize STEM is harder than they thought. It's not just rote memorization, it's actually applying these things to solving problems. And especially once reference tables come in, especially in the US where reference tables are the most used, when the reference tables come in, memorization is no longer needed. It's problem solving instead that comes in handy. Instead of having to memorize all the funky equations and symbols, and then only having to apply 2 or so theorems to get to the answer, now you don't have to memorize any equations. They're all there on the equation sheet. And instead you have to apply 5 or 6 theorems chained in a row, plus some very nice algebraic or calculus manipulations on the way in order to obtain something actually new. At least, that's what I would say if bachelor's degree college problems weren't so formulaic as well. It takes so much to get a PhD. You have to make a completely new discovery in mathematics. No matter how small, it's an incredibly hard feat to figure out something that no one has ever figured out before in the history of mathematics and science. So, most people, after getting their bachelor's degree, say that's enough. Or after they start their master's and PhD, they drop out, leaving only about 30 or 35% of those who commit to a bachelor's degree actually going for their PhD in STEM as well. So many people are becoming demotivated because of how formulaic our math and science has become. And you might say, well, isn't that the point? Formulaic sounds like exactly the kind of word to describe math and science, no? But it isn't. Math and science is dynamic. It takes more creativity than memorization to solve, especially now that we can look up any equation we want on the internet. Well, the point is, you can look up any equation that's already been invented, but you can't look up a new discovery. You can't look up how to be creative. All you can do is think about that problem-solving approach and do it yourself. But that's what so many of us struggle with, especially in math and science. Why? Not because we're dumber. Well, I mean, human intelligence hasn't regressed since the 1700s and 1800s, as our progress in many of the other fields has shown. Instead, it feels like math and science teaching and our approach to math and science has failed, or started failing over the years, as math and science, especially the front lines of math and science, become farther and farther from public view. No one will understand a single math paper. No layman will understand a single math paper that gets published in journals nowadays. Why? Not because they're too bored to read them or something, but rather because they simply just don't understand any of the concepts. There's too much jargon now. And not just that, but writing these papers requires lots of creative thinking and lots of jumps in logic. And these jumps can't be made by laymen or people who aren't experienced in the math and science field. So why aren't we taught to think creatively when it comes to mathematical and scientific problems? Isn't that like the whole point of math and science? To be applied in real-world situations? Aren't real-world situations very dynamic and require lots of creativity and specificity when it comes to every individual problem? And of course, that's right. Math and science need to be applied in a dynamic way every single time. But our teaching doesn't account for that. Instead, our teaching is the kind of teaching that gives the same problem with changed numbers 30 times in a row. Our teaching is the teaching that says, alright, find the circumference of the circle with radius 3. Good, now find the circumference of the circle with radius 5. Now find the circumference of the circle with radius 10. There's no actual creative thought to this, like for example, a circle is enclosed inside a square, or a circle overlapped with a square, what's its circumference? Instead, you're just made to plug in random numbers to random equations that you yourself don't understand the meaning of. And you'll only understand the meaning of them if you bother to go on further into STEM, at which point most of the people who aren't motivated or don't understand it already by studying on their own, they've dropped out. So it's just a systemic issue that keeps getting worse and worse. And at some point, only the people who who've loved math and science from day one, or the people who are being pressured by their parents, at some point, those are the only people who are going to be getting math degrees. The rest of the public is going to be almost completely math illiterate, and that's not the kind of future we want. Our children are the new tomorrow, and if they don't understand a single thing about math and science, imagine what our civilization is going to look like in 50 or 60 years, when all the children that we have now are going to be adults, or even old men who are going to be old people, who are going to be governing this country as well as my own country, the United States. Imagine what the world is going to look like if these kids that we have right now grow up without any exposure to math and science. It's going to be nearly a complete dystopia. So we need to fix this problem of lack of math awareness right now, right here and right now. So my suggestion to you is you have to talk to your children and ask them, I mean, what do you not understand? And if you're a child yourself, if you're still in school or college, tell me, how many formulas in math and science can you write down from the back of your head? How many formulas have you already stored in your head that you've memorized and that you could put down on a piece of paper right now? Now, once you've written them all down, maybe 10 or 15 of them, ask yourself, do you actually understand what's going on behind any of these equations? And don't give me a recited proof from a textbook that you put on an exam. Give me a real one-sentence understanding. Do you actually understand what a derivative is? Do you actually understand what it means to take the circumference of something? Do you actually understand what a surface integral is? I mean, if you don't, and you're just memorizing these equations for what they are on the surface, then you're never going to actually understand math as it is and its real creative problems in the world. And even if you do manage to get through your bachelor's degree with that approach, no one can make real discoveries if they can't think of anything creative in the first place. So, right here and right now is the turning point. So, please, ask yourself, what can I do to help myself understand better? And often it's not a problem of I have to listen harder or I have to read more. I mean, most of the time, rigorous students like those in India already do as much as they can in class. The point is, if class isn't helping you, you have to start focusing less on class and more on your outside resources. That's what I did personally. And when I say less focused on class, I don't mean skip the exams and tests. I don't mean skip classes. I just mean, for example, bring a book to class that you can read about the subject while the teacher is explaining something that you don't understand. And don't skip tests or don't fail your own tests. I mean, tests are simply there to see if you can understand the subject. So if you're actually studying on your own time and your own resources, you should still be able to pass them just fine. I know that's what I did when I couldn't understand any of my teachers. I would bring my own textbook to class and read that instead. So, so my message today is just to ask yourself, what have you memorized? What don't you understand? And you have to see, can you understand them? Because sooner or later, your perspective and your ideas about mathematics, your perspective on mathematics is going to be set in stone. It's being molded right now. But once you turn 18 or 19 or 20, it's very likely that you'll have a fixed attitude that won't budge. So you have to ask yourself right now, what can I do to help myself? What can I do to change my perspective? Thank you, and it's been my honor to be here at ERG Foundation. Oh, and one last thing before I end today's speech. I would love it if we could all stand up and sing the national anthem again. Punjab, Sindh, Gujarat, Maratha, Dravida, Utkala, Ganga, Vindhya, Himachala, Yamuna, Ganga, Uchala, Jaladhi, Taringa, Tavu Shubhe Name Jage, Tavu Shubha Ashis Mage, Kahe Tavo Jaya Gata Gana Gana Mangana Dayak Jaya He Bharat Bhagya Vidata Jaya He Jaya He Jaya He Jaya 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 He